We're going to look at the types of machine learning algorithms. We have two types in this instance. What we're going to look at, what we call supervised learning. With supervised learning, basically, we have data that we already have given labels. In this instance, we look at some of this data that is labeled as tomatoes. We give each tomato a label. We have carrots, well labeled, and bell peppers. We provide this data to the algorithm. The algorithm is able to understand these labels as they are. And then when you provide it any other data, it's supposed to predict what it is. So basically with supervised learning, you provide labeled data to the algorithm, and then it's able to predict what is provided. With unsupervised learning, the data that is provided is not labeled. So you provide the unlabeled data to the algorithm. It looks at it, processes it, understands the patterns, and is able to determine what is the data. For example, here you can see it has categorized the bell peppers alone. It has categorized these others alone and the onions alone. This is where you have unsupervised learning. So you provide training data, it understands the data, the model, and is able to make a prediction when given new data. That is what we call supervised learning. Same thing. If you provide it with data like spams and good data in your inbox, it's able to look at this training data, understand the patterns, and then when an email comes through, it's able to predict that it's a what? It's a spam. Let's do another example that I want to use for housing prices, whereby we'll use now this time. I want to show you how you can do it by loading a data set. This is a simple example which is also provided where you have 1,000 square feet, 500, and then it has 3 bedrooms, age is 10, and this is the price of the house. We did a similar example previously where we were able to determine the house prices, and we were able to plot. We didn't plot previously, but now this is what the plot would look like. Basically, the x's will be the training data that we have provided, the data points, and then the green line will be the land model, and then x will be the prediction given. We're giving it a certain input feature. It's able to determine the house price. We're going to do this in code and see what it will look like, what it will do for us coming soon. An example of the labeled image classification. You want to build a model that can look at a picture and tell if it's a cat or a dog. You provide it with pictures of cats, dogs, with all the given labels. From there, then you provide, as you can see here, you provide different data, and then you make a prediction. Same thing applies to email classification, provided with data. For example, some of our emails will have things like win a free iPhone now. That will be labeled it as spam. Meeting at 3 p.m. That would be maybe because let's assume that is your good email, not spam. Congratulations, you've won a prize. Usually these are spam emails. People tell you you won a lottery which you didn't even participate in. So some of these normally have these kind of phrases. So this is normally labeled as spam. So you have all these emails that have been classified as spam or not spam. For example, you have an invoice for your recent purchase. This could be not spam, okay? So we categorize the email spam and non spam as training data, feed it to the algorithm, and then it's able to classify whether an email is spam or not spam. So with the supervised learning, you have labeled data. With unsupervised learning, you have unlabeled data. This is what we're graphically trying to explain what if a prediction is met. So we did look at the mathematics for linear regression in simple. We did look at this previously. Y is equal to mx plus b. We explained this. We explained how the calculations are done behind the scenes, but this is basically how it's calculated. Usually, if you were to do it manually, but all this computation is going to be done by our Python code. So let's look at another example where you use the linear regression model. We're going to upload a data set and give it several examples, call our libraries, call Panda for handling the data, load a data set. I will show you the data set. This is an example of a data set we're having right now. We are having square feet of the houses and the price of the houses, and you want to make a prediction. So let's go to our collab. So let's say first thing we import the libraries, the Panda and NumPy. Panda is for data handling. The NumPy is good for numerical operations. Then we have the linear regression model, which is called from scikit-learn library. And then matplotlib, which is used normally for plotting. We get that, and then we load the dataset. The dataset that we just showed previously, we're going to load it. Let's load it here, and here we go. Let's get this dataset we had. As it's loading here. Give it a few seconds to load. Good. Here's a dataset. It has loaded that we had shown previously. Let's get the path. Copy the path, how to get to this dataset. Place it here on this code. Okay. So this is the name of the dataset. House price dataset, this one, and the CSV file. We place it here in the code. And then we get the X values. Basically, it's going to capture all the X values and the prices of each house. So we have the X's and Y's. Our X's were the square footage of the house, and our Y's, as was shown previously, with the price of each house. In this instance, we have only one input feature and one price to predict. So if we train the model scikit-learn, we specify the model, then we fit the model. Basically, we train the model to figure out the slopes and the intercepts. If we run this, it will give us the slope and the intercept. Then here we want to make a prediction. So in our code, basically, we're telling our code, the code is telling us put in a square footage you want, so that is able to compute for us the house price prediction. Let's say right now the square footage of the house is 6,000. Let's enter that. So from 6,000, it's able to predict that the house price is 952,142. That would be the price of the house. From our code, it has considered the intercepts, the weights, and the data that we had provided to it. We can plot this graphically. Let's plot this. If we plot this, we'll see something like this. As you can see, as the square footage increases, the house prices also increases. And we can see, like, if our house is 6,000 square feet, it's going to be around this price. And that is a simple model that is shown. This is a little bit going up. We need to adjust this for this blunt line. We need to fix this part. But this is an example. Basically, we can improve this code always to be able to show us the whole line going through. But this is just a graphical representation of house price versus square footage. So technically, our house price for 6,000 square footage house is going to be $952,142.